7.2 expressions combining like terms and exponents. Remember that an expression does not have a solution. It can be simplified. What that means is there is no equal sign, but it can be simplified, and I'll show you why, because that would be talking about combining like terms. Remember that x by itself means 1x and negative x means negative 1x. So some expressions can be simplified by combining those like terms. When you combine the like terms, make sure that the term is the same. For instance, it's like a family. So your family, you have to combine things that are alike. So a coefficient and a variable, you have to look at the variables. And if they are all x's, then you can combine them. If they're all y's, then you can combine them. Then you look at your constants next, and you can combine all those. So those are what you can combine. You can't combine the variables with constants, and you can't do constants with variables. So 4x plus 3y plus 7. How many different terms do you have there? There are 3 different terms there. 3 different families. We have 4x plus 3x plus 7x. How many x values do we have? We have 3 x's, so how many different terms? We have no different terms. We have one family. So if I were to add that, 4 plus 3 plus 7, that would give me 14x. So next, we're going to talk about exponents. So base is the number that is being multiplied by itself. So the base is important. This is the number, once again, that you are using to multiply. So for example, if I have 9 squared, 9 is the base. If I have 6 to the 4th power, 6 is the base. So now if I have an exponent, that determines the number of times the base is being multiplied by itself. For instance, 3 to the 5th power, the exponent would be 5. 2 to the 7th power, 7 would be my exponent. So if a number is being raised to the 2nd power, it's called being squared. If a number is being raised to the 3rd power, that is being cubed. Those will come up a lot when we're in geometry. Next, we have an expanded form. Expanded form means that you're going to take the exponent and the base and the exponent, and you are going to show the full multiplication process. You're going to stretch it out. So if you have 3 to the 5th power, you would write 3 5 times. So that would be the expanded form. Now, the standard form is the number that is being raised to the power, or when the number is being simplified. This is your answer. This is your solution, or it's your answer. Okay, you're solving. So standard, solution, or solving. It's your answer. So now let's look at combining like terms again. So I like to combine them by circling or identifying them in a color. So if I have n minus 10 plus 9n minus 3, I see that I have 2 n values. So I'm going to have n plus 9n. You notice that the sign went with it. And then I have a negative 10 minus 3, or a negative 3. So I can combine my n and my 9. The number that's in front of just an n is always a 1. So 1 plus 9 is 10n. And then if I have 2 subtraction signs, we're going to add and keep, which means I have a negative 13. And that would be your solution, or that would be your expression. These are expressions. I look to see if I have, so I have a 4x. I have no more x's, and then I have a 10, and I don't have any other constants, so my expression would be 4x plus 10, and that would be it. If you're struggling noticing the difference between coefficients and variables or what to combine, you can always make models. And I'll show you that now. So I have an e plus 4 minus 9 plus 5e. So I have an e plus 5e. And then I have a positive 4 minus 9. So I'm having a hard time seeing what I need. So I have 1e, 2, 3, 4, 5, 6. So I now have 6e. And then I had 4 positive. And I have 9 negative. Okay, I'm going to zero out my 0 pairs. And I'm left with 1, 2, 3, 4, 5. And all those are negatives. So my expression here is 6e minus 5. All right, so now let's look at our powers, our exponents. So 2 to the third power, my base is 2, my exponent is 3. My expanded form, remember, is it stretched out, which means I'm going to take my 2, and I'm going to go 2 times 2 times 2. My standard notation is my solving, okay? So 2 times 2 times 2, which means I'm going to do 2 times 2, which is 4. I'm going to bring down the next 2 and do 4 times 2, which is 8. Remember, you are multiplying by the same value. Next, I have 8 to the third power, which means I'm going to do 8 times 8 times 8, which looks like 8 times 8, which is 64, times 1 more 8, which means I'm going to do 64 times 8, which my solution here would be 512. Next, my base is a 5. My exponent is a 4. I'm going to take my base and I'm going to multiply it times 5 times 5 times 5 times 5. So that means 5 times 5 is 25. And I'm going to do another 2 5s. I'm going to multiply those two values together. So 25 times 25. Make sure you are multiplying those values together and you're not doing any other operation. So 6, 2, 5. Remember, if I am solving too quickly, please pause it, write it, solve it, and then you can always play it again. Next, I have 10 to the third power. The base is what? The base is 10. The exponent is what? 3, which means I'm going to do 10 times 10 times 10, which means how many zeros do I have? 3. So that would be 1,000. The base is a 7. The exponent is a 2, which means I'm going to do 7 times 7, which is 49. So please be careful here that you have a negative 3 to the third power. So the base is the whole negative 3. The exponent is a 3, which means I'm going to do negative 3 times negative 3 times negative 3. If I have a negative times a negative, what do I have? Hopefully you thought a positive. So negative 3 times negative 3 is a positive 9. I then am going to bring down the negative 3. So 9 times negative 3, I'm left with a negative 27. So hopefully that answered your questions and you can write that down. Of course, if you have any more questions, please don't hesitate to let me know.